Hello, my name is Irwin. I'm the Managing Director in Northern Europe with Konrad, and today I'd like to give you a demonstration of a signaling feature of our 2400A radio frequency communication tester. In this case, demonstrating how we're going to use that signaling for throughput testing and Wi-Fi. So behind me here we have a lab view example. So I'm going to connect to the instrument over a particular IP address. It will connect to the device and we'll set up the instrument as a Wi-Fi AP access point, you can see here. And then it's going to run an iPerf server. Now iPerf is a kind of pretty standard way of doing throughput testing, whether it be over the air or by, say, Ethernet, for example, by cable. You can see here I've immediately connected to a phone which I have in my hand. This is a typical iPhone, and you can see it's pulling back the RSSI, the received signal strength indication in dBm, and we're running a constant ping to that device, that client as well. What you can see is that ping or RSSI will differ as I move around. If I move away from the instrument, you'll probably see that the RSSI will degrade slightly as I move away from the box. And as I move quickly closer to the box, that will also increase. You can see they're up to about minus 62.5. So it's showing that this is a real over-the-air link with the access point. What I'm now going to do is I'm now going to run the iPerf client on the iPhone. And you can see that here on your right-hand side beside the lab view. If I launch that there, I'm going to send traffic from the client to the iPerf server. Now in theory, you probably could get about 150 megabits per second, but of course this is a real practical example. We may have some degradation, of course, over the air by interference, etc. So here I've set up a number of different packets, different sizes. I think it's set up to run for so many seconds, and what you'll see at the end here is that we have an idea of what our throughput was for each of our settings at the end, and we can show that equally on a graph. But this is just to give you an example of how you can use the access point within the instrument, connect to indeed multiple clients, multiple mobile phones, and do some simple throughput testing, which is giving you an ability to do feature testing of products. Now this is particularly useful for the primary use case of this instrument, which is end-of-line testing. Now end-of-line testing, you really have two goals. One is to do some simple RF parametrics, and the second is to do some throughput testing. Well, what I'm showing you here is how you can do that throughput testing. Equally, you could pull back your RSSI, as you can see, some RF parametrics. You could also use the non-signaling side of the instrument to do more advanced testing, maybe power and frequency, or indeed do a demodulation of some of the transmissions from the phone, or do packet error rate testing as well. So it's a really flexible, low-cost platform, giving you the range of capabilities for a number of different use cases.